Hello guys, welcome to Examalist, and in today's lecture series we will do the application part. Okay, so we have done a lot of theory about the entire quantum mechanics and physics both in our previous lectures, and in this lecture we'll see a particular application of the theory that we have learned. So what do you mean by particle in a box? So a particle in a box means you take two walls here. Okay, so we are dealing with 1D. Okay, please remember we are only dealing with 1D till the starting. We are dealing with only 1D. Say this is the x-axis. Okay, and these two walls are such that the potential here is infinity and the potential here is also infinite. That means if you place a particle, then the particle cannot go to the other side. As it means it cannot jump the infinite barrier. Okay, so when I say infinity, so what is infinity? The potential. That is the potential. This side is infinity and the potential here on the other side is also infinity. Now many people, they make a mistake. They think that it's a box. So you have two walls and you confine this some particle in between the two walls. Okay, and then many people again visualize this as, okay, you take two walls, okay, like in classical mechanics walls, and you place a ball in between and the ball is bouncing. Okay, so this is entirely wrong. Please see, when I say there are two walls, these red color lines are not the walls that you generally see in your day-to-day life walls. These are not material walls. These are walls of potential. Okay. So let me give you an example of a potential wall. So consider a metal. Okay. So if you have a metal, then the surface of a metal can be considered as a 2D wall. It means the potential on all the four side is infinity. Okay, and if you have a free electron in the metal, then you can imagine that free electron is in a 2D potential. Agreed? So so this is the example of a 2D surface. So for example, so what I mean to say is that if you have metals, the metals have free electrons. All the free electrons of the metal, they form the conduction electrons, and these conduction electrons generally flow on the surface of the metal. Now remember that the electrons cannot come out of the surface of the metal until and unless they are given some energy. So we are not talking whether they are given energy or not. One thing is for sure, that these electrons, which are the free electrons of the metals, they cannot come out of the surface of the metal. As a result of which, we can imagine the entire setup as the same. This electron that I am drawing here is actually the free electron, and since it cannot come out of the metal surface, then I can imagine the metal surface as a 2D box. Okay. But so when I consider it as a 2D box, it means there are potentials all along the box which is not allowing the particle to come out of the box or to come out of the metal surface until unless it is given some energy such that it pierces the potential. So if it has energy more than the potential, only then it will come out of the box. If it has energy less than the potential, then it cannot come out of the box. Okay, so I hope you understand what I'm saying. Whenever I use the word as box, when I use the word as wall, these are all potentials. Okay, please remember that these are all potentials. So let me give you one more example. So if I draw a diagram like this, if I say, okay, there is a potential here and this potential is finite. Okay, and a particle is coming towards this potential, and you would say that, oh, this is a wall, this is a finite potential wall, and a particle is coming towards the wall. No, it's not like that. It's actually what? So consider a positive charge. Okay, so say this charge is plus q, is freely coming with a particular energy E. Okay, so when I say there is a potential here, just imagine, say there is a say there is a big collection of positive charges. Okay, so this circle contains so many positive charge, like red. Now when I say this circle contains so many positive charge, then it has a large positive charge. It means it will create a what type of potential? It will create an attractive, it will create a repulsive potential that will try to repel this incoming particle. Okay, now if the energy of the incoming particle is so large, then what it can do is it can just pierce the potential and get out. It means this potential is not sufficient to stop the free particle, because the particle now has an energy much larger than the potential that it encounters in its path. However, if the energy is small, if the energy of the incoming particle is very much less, then what will happen? The only thing that will happen is that the electron will face the positive particle will face a huge amount of repulsive force, and it will repel and it will get back. Okay, it will get back, so it cannot move forward. So when you look at this diagram in future, we will do this diagram. Okay, this type of diagram we'll do in future. So when you look at the diagram containing a wall with a potential, then please understand these are not the classical walls that it has to pierce. So whenever we are talking this type of things, it actually means some potential generated by some source. So whenever in future I will write a potential, it means there is some source that is creating this potential, and you know what type of source creates potential. Okay, so I hope one thing is clear, that when I'm talking of particle in a box, then you see that both side the potential is infinite. That means there is some source, there is some source somewhere, there is some source somewhere which is responsible for this infinite potential both side. And because of this infinite potential, this particle inside is not able to escape the potential. And this is the system that we will study in our next lecture. So how quantum mechanics describes a system like this, and what are the results we get from a system like this. And you will see in the next lecture, quantum mechanics predicts some really crazy results that is way out of the classical intuition. So you cannot even have any intuition of the result. First of all, you will think it's not true, but trust me, it's true. Okay, so this is what quantum mechanics is. Sometimes it may give you results that is not even intuitively clear. So in the next lecture, we'll look at this entire system in a more mathematical approach.